Good morning, everyone. So today we will begin with yet another exercise on vectors. In the last class, we had observed about what is a vector and how do you do addition of vectors using GeoGebra, right? And now what we will do is we'll learn about what do you mean by a resolution of a vector. Resolution of a vector. Okay. Now towards it, first let us understand a vector. Let me just recap. A vector is nothing but it's an entity which has both magnitude and direction. This is what you call as a vector. An example of a vector could be velocity, could be acceleration. So these are some of the examples of vectors. Now let us say I am drawing a line like this. Now a line is just a line in mathematics. But if it comes in physics and I say that this line is a vector, then what I need to do is I need to describe the length of this line, which can be somewhere around, let us say 5 centimeter. And what is the direction? Where is this line heading to? Okay, so the line can be heading in this direction or it can be heading in this direction, right? So therefore I can have one line like this. I can also have a line like this. Now, if you ask me what is the difference between these two lines, A and B, then I would rather say that A is along the positive x-axis, while B is along the negative x-axis. That's what I can say. I'll write it on minus x-axis over here. Okay. So therefore, now I can say the vector A can be written as positive vector, while the vector B can be written as a minus B vector, negative vector. I can say something like this. Now, with respect to what did I coin or how did I term that this is positive and this is negative? With respect to a reference axis. What is the reference axis? X-axis. Okay. This was used as a reference axis. And based on this reference axis, I had suggested that this could be a positive vector, and this could be a negative vector. On the same lines, if I consider a vector like this, now what do you say? Will this be a positive vector or a negative vector? This would also be a positive vector. Why is it a positive vector? Because you considered this as your positive y-axis, and this line is parallel to this line, and it's along the same direction. And as a result of it, you said that this is a positive vector. Now, if I had drawn a line, a vector like this, then what do you suggest? Your answer would have been this is a negative vector, right? Thus, we are able to now say which one is a positive vector, which one is a negative vector. Now I have a question. The question here is that if I have a vector like this, okay, now what is your reference axis? Your reference axis either should be along x-axis or it should be along y-axis. Okay, now what is so special about this vector? In this vector, the x vector, okay, it is now you see, it is neither aligned along the x-axis nor aligned along the y-axis. And moreover, this is a two-dimensional vector. What do you mean by two-dimension? Two-dimension means in order to represent a point on this vector, let us say I want to represent this point P over here. Then what I should do is I should represent that in order to reach the point P, its coordinates are x comma y. What do you mean by x comma y? Which means that from the origin, you move x units towards the x-axis, y units towards the y-axis. And that's what you got as xy, right? That's why, so to specify a given point, you need at least two coordinates. That is what you call as a two-dimensional vector. Now, next what we do, we have learned what is a vector. Now, based on these lines, can you say what kind of vector is this? This is a one-dimensional vector. Why one dimension? Because you see, you just need only the x coordinate here. The y coordinate is always a 0, right? See, the y coordinate is always a 0 here. Everywhere, the y coordinate is 0. Only the x coordinate is increasing. In a similar way, what kind of vector is this? See, this is also a one-dimensional vector. Why one-dimensional vector? Because you see, this is my x-axis. This would be along my y-axis. And thus you say, the x coordinate at every point here is 0, right? Okay. So now we have understood about two dimensions, which I will be looking into in the area of kinematics. Now, before that itself, we have learned it. Now, coming back to this. Now, I have a vector which is arbitrary, and I observe this vector is a two-dimensional vector. So, these were one-dimensional vectors over here. This is a two-dimensional vector. In a two-dimensional vector, both x and y are varying. Both are varying. Okay. Now, if that is the case, now how do you represent whether it's a positive vector, and if it is a positive vector, negative vector, and what direction, what is your reference axis that we take across? That is not known to us. Okay, that is not clear. So towards it, what we do is we consider this is our xy coordinate frame, xy coordinate frame. Take the vector of interest. This is the vector that you were asking. So put this vector like this. And now what you do is, let me call this angle, this line, this point is P over here. This point is O over here. Let this make an angle theta. What is theta? Theta is the angle made by the vector with respect to the line OX, right? This line OX is nothing but the x-axis or horizontal line. Now for our memory, for our understanding purpose, I will call that these two are two neighbors of this line. Can we call that as neighbors? N1 and N2 are two neighbors, of course, right? Who is a neighbor? A neighbor is somebody who is staying just beside me, right? My sister stays next house, then I can say that she is my neighbor over here. My friend stays this side, then I can say my neighbor is my friend over here, right? So therefore, these two are the two neighbors. Now we ask the question, what is the component of OP along x-axis? Now we should ask the question, what do you mean by component? We introduce a new term here, right? Component means the contribution of this OP along the x-axis. Why contribution? Because you see, here we did not ask this question. What is the reason? Because you see, the entire vector was lying along the x-axis. But here, part of the vector is lying along the x-axis. Part of it is also along the y-axis, right? So the vector is due to the contribution of both x and y coordinates. So we are now looking at what is the contribution of OP due to the x-axis, right? So we ask this question. To answer this question, what we do is we just draw a perpendicular here from P to this one. Let me call this point as A. Now what we do, we will write cos theta. What is cos theta? Cos theta is nothing but in this right angle triangle OPA, in triangle OPA, triangle OPA. Cos theta, what is cos theta? Adjacent divided by hypotenuse. Now, what is adjacent here in this triangle? OA is the hypotenuse. Adjacent. OA is the adjacent side divided by hypotenuse is OP. OP over here, right? Now, what did I ask? I asked, what is the contribution of this line along the x-axis? The contribution of this vector along the x-axis is nothing but OA. Now, why OA? One more question. Now, the simplest way to answer this is that take a tube light, put it over here. A normal tube light, put it over here. Now, what will happen? Light will fall onto this. Okay, let us assume that this is a rod hanging over here. Now, when the light falls onto this, it will cast a shadow here, right? It will cast a shadow over here. So the length of the shadow definitely is not equal to the length of the rod over here. Imagine that is a rod. OP is a rod. Okay. So now this OA is nothing but the effective contribution of OP along the x-axis. So therefore, now OA, I will write this as contribution due to x-axis, or in math or in physics, we call this contribution as component. Okay. So just what is component? OA is a component, which means now I can write OA is equal to OP cos theta. Now, if I ask the same question, what is the contribution of OP along y-axis? What do you do? Drop a perpendicular to the y-axis. Now, this would be, let me write this as B. This OB would be the contribution of the vector OP along the y-axis. Now, how do I get this value? If this angle is theta, then now let us look at the opposite. So let us take sine theta. Sine theta is equal to AP divided by OP. What is this? This is your opposite side divided by hypotenuse. Thus, AP is equal to OP sine theta, right? So thus AP equal to OP sine theta. Okay, this is a vector, and thus we have divided this vector into two parts. What are those parts? One along OA, the other along OB, right? Okay, now we have so far learned about the physics behind it, as how do you get these vectors. Now let us go directly to the O Physics website, right? Okay, so now what I've done is, let me show you where is this website available. So the website is this website. See here, this is not done by me, it is done by somebody else. Okay, so I always think that using the other resources fruitfully is like advertising to them, but anyway. Okay, so this is the website which I say, if it is useful for us to learn, then definitely we should make use of it, right? Okay, so therefore, now you see this website name is known as ophysics.com. Okay, let me write it down. Oh, maybe I have not shared my screen. Okay, let me share my screen also. Let me write down the website initially. The website name is ophysics.com. Right, that's the website that you need to go. Now what I will do is, let me share my screen once again. Okay, I had not shared the screen earlier. Right, now you see, this is known as the website is known as ophysics.com. Now let me share my screen once again to go to the website. Now we have opening the website. Right, now you can see this is the website that we have, as you notice over here. So you have home, you have kinematics. Let us go to kinematics, and let me click on vector components. When I click on this, I get OPhysics interactive physics simulations vector components, and thus it opens an applet over here, and I'm able to see this one. Right, let me have it like this. Now as you see, this is the vector. I can now pull this vector, zoom in, zoom out. Okay, now what I can do is, I can make this theta equal to 0. See, there's a slider here. I'll make this theta equal to 0, and I can draw the length of the vector to be, let us say, for example, I want only for 100 units exactly. I can, do I need to type it? Yes, I can type it also here. Maybe I'll make it 50 units, or yeah, 100 units will be fine. 100 units. I typed in the 100 units. You see, the vector is now seen to be 100 units. There's a vector which is an arrow here, and there's a length here. And it says AY equal to 0. Don't worry about what is AY. So it says AX equal to 100, which means the vector is along the X axis. Right. Now what I do is, I will now change the angle. If you remember, the vector which we drew earlier was not along the X axis nor along the Y axis, but it was making an angle over here, right? So I will change the angle here also. How much that will change? Let us change this to 10 degrees. I have typed 10 and put it over here. Now you see here, this value of AX, earlier it was 100, now it has reduced to 98.5. And this value has become, AY is 17.4. Why did it become like this? See the sum of these two, AX plus AY, is not equal to 100, and it can never be equal to 100 also. Okay, so I'll teach you in another class how do you get this value, or maybe if you are able to think and let me know. See, the value of A here is nothing but 10, and this is a right angle triangle here. This AX is this line, and this length is nothing but AY, which is 17.4 units. So in a right angle triangle, you can use your Pythagoras theorem, and thus you say 98.5 square plus 17.5 square is equal to 100. You can get this value. Okay, now what we'll do is, let us change the value of the angle. Now imagine, instead of making it as 10, if I make it 20, what do you expect? Will the value of AX reduce or will it increase? Now, as you rightly pointed out, it will reduce. I'll make it as 20, and then press the enter. You see, the value of AX has become 94 over here, right? Now, similarly, if I reduce this much more, 30 degrees, what is that you expect? It should be much lesser. See, it was earlier 94, now it has become 86.6 over here, right? And now next, let me go to 40 degrees. Now you see, it has become 76.6 volt. Now, is it reducing in an appropriate decreasing way? Let me ask you the question once again. I started from 10 degrees. My value here was seen to be 98.5. So can I write it over here? I will not be able to write over here. Okay, I'll do one thing. Just give me a moment. I will share it over there. Okay, I can write it in my PPT itself and I can show it there. Maybe if you have the, yeah, now let's do physics over here. Just a moment. Let me maximize this PowerPoint slideshow. Share. Just give me a moment. Right. Now, what did I say? I'm doing an experiment here in physics, okay, with the simulator engine. Now, whenever we do an experiment, what we need to do is we need to write a table. Why a table? Because we need to record the readings. Now, what so special experiment I am doing? Let us write down what am I changing here. Okay, let me show you once again. What is that I am changing? I am changing the value of theta here, right? And what is that I am monitoring? I am monitoring the value of AX over here, right? And also, if you want, I can monitor the value of AY also. Okay, so towards it. Now, what we do is, let me go back to my presentation and I will write theta, and then I am monitoring the value of AX. I'm monitoring the value of AY. While doing all this, I am keeping something constant. What is that constant? The value of A, the vector, magnitude vector, which is equal to 10 units. I am keeping this constant. Now, the first trial, when I kept this at 0 degrees, what was the value of AX and AY? AX was also seen to be 10 units. AY was seen to be 0. Second trial, second observation, not trial. Trial means which comes in the horizontal way. Now, when I keep theta is equal to 10 degrees, what did we observe? Let me go back to this. What did we observe? We observed the value of AX was seen to be 98.5 and AY was seen to be 17.4, right? AX is 98.5, AY is 17.4. AX is 98.5, 98.5, and this is 17.4. Okay, now let us write down a few more readings like this. Okay, because I want to ask you some important question here. 4, 5, 6. Since I said this is an experimental physics, I'm not going to teach you theoretically everything. So we need to learn everything from an experimental point of view, right? So therefore, when you have an experiment, you will definitely have to do an experiment and record the readings, right? And especially for the MYP or the IB boards, this becomes very, very important. Now see, I am varying this one here. Okay, let me share it once again. Let me go to 20 degrees. Let me change it to 20. Go back to the slider. I'll make it as 20. When I make it 20, I get the answer as 94 and 34.2. 94 and 34.2. Let me write it down. That also. So this is 20, 94, and 34.2. The next variation could be 30, 40, 50, 60, and I will be doing this. I'll write it one more table here, which will be a continuity of this SL number, theta, then you have AX, and then you have AY. Okay. Since we are doing an experiment, we should complete it. We should not just do half-heartedly and then say we haven't got anything, right? Okay, so 30. 30, what is the value for 30? Let us do that also. 30. Now let us change this to 30. 30. How much am I getting? 86.6 and 50. 86.6 and 50. So write it down here, 86.6 and 50 degrees. Next, for 40. We change this 40, 76.6 and 64.3. Remember this value, 76.6 and 64.3. 76.6 and 64.3. Then let us change once again for 50 for more trials. 50, 50. 64.3 and 76.6. 64.3 and 76.6. 64.3. Hey, look at this. See, there's a reversal here, right? Now, maybe for 60 degrees, I will just write down. I do not know whether it is right or wrong. I need to check it out. 86.6. Okay, maybe for 70. Okay, first let us check out for 60 and see whether I get the same answer. What is the answer? I should get 50 and 86.6. Because what I did was, I just reverted this. See, here it changed. So I also change over here. If that is the case, I need not redo it again and again, wasting my time, right? Okay, so which one we are going to do? 60 degrees now. We haven't done 60. So 60. 50 and 86.6. Wow, there's something really magic here. Yeah, I never thought this would happen. 60, 50, and 86.6. 50% of my work has been reduced. 70. What should be the value of 70? So what I'm doing here, I kept on going like this. When it came over here, 76.6 and 64.3, then 50 and 86.6. Then they should be 34.2 and 94. 34.2 and 94. 94. Next one should be 17.4 and 98.5. Last one should be 0 and 90. Okay, this is what you should expect. I made a mistake, I think. Yeah, this is my theta. This is my AX. This is my AY. And this is nothing. Right. This is what you see. So which means when you increase the value of theta, okay, what are your observations? See, any infographic, any tabular column that you write, it should have always have some relevance. It should have some conclusion. The conclusion here is that when theta is increased, right? I'll write the conclusions here. From table, this is a raw data collection. From table, what is that we inferred? We inferred that if theta increases, AX also increases until where? Until 40 degrees that we have seen. Until 40 degrees. Then, and AY decreases. If theta is increased beyond 40, then what happens? AX decreases, AY increases, right? Until 90. We have seen this. Okay. And then, does it mean that theta and AX are proportional to each other? Do you have an answer for this? Third one is theta and AX. Are they proportion? Are they in proportion? See here, when you double this, this does not get doubled over here, right? If this was proportioned, then what should have happened is, hey, this was 100 over here. Yeah. Okay. If this was doubled, this should have been doubled over here. Definitely that is not changing. Now, can we say it is inversely proportional? If it is inversely proportional, what should you say? You will say that if it is inversely proportional, then if you double this, then this should get halved. If you triple this, then this should get 1/3. Is anything like that happening? No. Okay. So theta and AX are not, are only, they are not inversely proportional or directly proportional, or directly proportional. So this is one thing which is very, very important. In most of your papers, they will ask whether theta and AX are directly or inversely proportional. You should be able to answer it. Okay. Most of them, 99% of them, they answer that it is inversely proportional here and directly proportional on the other side, which is incorrect. Okay. Make a note of this. Right. Now, what is that we will see? Okay, let me go further. Fine. So we have now learned how to resolve a vector into two parts, right? Ax and Ay. So with this for today, we will stop here. Next class, we'll continue with the addition of two vectors. Once again, when two vectors are making an angle theta. Thank you, friends. Thank you for watching. Like, subscribe, and share this channel so that it reaches the masses. Thank you.